Hello and welcome to Season 2, Episode 28 of LogiCast, the AWS News podcast brought to you by Logicata. I'm John Goodall, Lead Cloud Engineer at Logicata, and I don't get to say as always about myself, but I am always here. Karl is once again otherwise unavailable, and we continue to wish him well and continue to wish that he would be available, because I don't want to host this, Karl. Please come back.
Yeah, get well soon, Karl.
I only have the one guest this week. We have Omkar Kadam. If you'd like to tell us a bit about yourself, Omkar, that'd be great.
Sure. Thanks, John. And hi, I am Omkar Kadam, and I am currently a lead DevOps engineer. I got promoted today. So yeah, this is the first public announcement via your podcast. Uh, in my work with cloud technologies, I mostly use AWS and help production support as well as platform engineering tools teams to deploy software successfully. And if in case of any mishaps or anything gone wrong, we help them to get it to a safe state or roll back and revert as safely as possible and as quick as possible. So yeah, it's pretty exciting stuff.
That all sounds quite cool. That sounds a lot like we do generally as Logicata, helping customers to deploy things cleanly, swiftly, and efficiently. And then if it all goes wrong, which in tech it inevitably does, helping them get back to a place where their production environments are all running. So that's all cool. This is also a first for Logicast. So we've made, I'm not sure we can claim the credit, but we've made a couple of AWS heroes. And now this is the first promotion announcement that we've had.
Yeah,
Shame it's not mine.
It's great.
Good stuff. Promotions are always cool. In normal fashion, we have 5 articles to go through this week. They are normally picked from a newsletter, but that newsletter absent this week. Apologies for that to anyone that is both a regular reader of our newsletter and listener of the podcast, but we do still have the 5 articles that we have picked out for the podcast. We are going to go through those in the normal fashion. So without further ado, let's get going. First and foremost, we have an article on Dev2, Ken Collins, one of the AWS heroes, which is always nice. We like talking about the AWS heroes. We like talking about the things that they write. We've had actually one active hero on the podcast, as well as 2 heroes before they were heroes. So nice to kind of bias towards those articles. What we have here, it's titled Goodbye Cold Start, Hello Proactive Initialization, with lots of emojis in the title, because everyone needs emojis in their titles. Don't get it, but there we are. What this one is going on about, what this is saying is, since about March of this year, and for posterity reasons, that's March of 2023, in case this podcast does go on and on and on, which it might, AWS might have solved some, so this is couched quite heavily, of your cold start issues with proactive initialization. So functions using on-demand concurrency, previously, if they hadn't run recently within kind of the last 10 or 15 minutes, would be redeployed to the execution environment, container that they run in, which we're not meant to know it runs in containers, but everyone knows it runs in containers. Don't get it. Would be redeployed to the execution environment, container would be repulled, everything would be restarted, and your first start would be rather slower than your subsequent ones. I have personal experience of, say, Python containers, Python Lambdas, on a cold start starting in sort of 3.5, 4 seconds, and then on a warm start starting in, a couple of hundred milliseconds. So it's definitely a thing. And there have historically been a number of attempts at dealing with this. You can either reserve concurrency, provision some concurrency, which means that it's there and it's running, but you're always paying for it. There were some dirty hacks around calling your endpoint arbitrarily once every 10 minutes to keep things warm and kind of weird things like that. But according to this article, and it refers to another one as well, AWS may have solved this with proactive initialization. And what that's basically doing is when your execution environment starts to spin itself down, it will reinitialize itself again automatically for you, which is really cool. A bit odd. I mean, from a cost and AWS perspective, a bit odd, but quite cool. I don't know how much you do with serverless, Omkar. I don't know if you want to come in on this.
Yeah, sure. So what I think with this article has really been a great point is AWS is trying to own the scaling challenges, and they are trying to actually, with the snap start feature as well as proactive initialization, they are trying to get a shared responsibility model and trying to own and solve this problem for all their customers, so that they can the customers can only focus on their business logic or the actual handler code, and AWS AWS is a hyperscaler. It manages all the scaling and the heavy undifferentiated work at the back end. So yeah, it's a pretty good and cool feature, which is what I think.
It's an interesting point because with Snap Start, it's almost like they admitted that cold starts were a problem after having spent a very long time saying that they weren't a problem and that you should just work around them and that they didn't exist and all the rest of it. And then they kind of admitted that they were a problem, and more for like your Java runtimes than say your Python and your Go runtimes, but that they were still a problem. I think this is more accidental than deliberate on the part of AWS. Like they obviously deliberately built the feature, but it feels like it's not a feature that was on the roadmap so much as something that happened anyway because of something else they were building. I don't know. It's all conjecture, but it's definitely them taking more ownership of this problem.
Yeah.
Worth also saying as well that with some custom CloudWatch metrics, you can actually see how often this is happening. This is what the dev.2 article is talking about. And it's talking specifically about a large Rails app that's running lots of data, which is where cold starts are going to be painful because, you know, in your small APIs, it's only a couple of hundred lines of code. They come up really quick, they run really quick, they go away really quick. It's kind of not a problem. But in your larger environments where your apps are, you know, many thousands of lines of code or they're moving lots of data around, it's a real thing. It's a real problem. And this graph is quite interesting because it's showing that over time, you're still getting a little bit of cold starts. It's hovering kind of around the 10 to 20% mark, looking at that graph, but it's progressing very rapidly to more proactive initializations and cold starts, which is really cool. It's a nice feature and I like to see it.
Yeah, it shows like around 80% of initializations are proactive and cold starts are very minimal. So yeah, it's a great step, and I really congratulate AWS on launching this.
From faster Lambdas, it's a nice little segue into faster container startup using Seekable OCI. Now, this isn't something I'm massively familiar, and you wanted to talk about this one, Omkar. So why don't you give us the rundown?
Yeah, sure. So with Seekable OCI, what AWS is trying to do in the containerization space is it is trying to index and make the initial load time of containers or any images that you get from ECR and make it fast. So in the sense that Docker images are having separate layers and those layers are sequential in nature. So the entire load time or the provisioning time of your container is a lot if it does not use indexing of any kind. But what with this feature they are trying to have an index for every image or every container that you upload to your ECR, and on scratch they are trying to rebuild or use the same index to get or to offload some time from your initial loading time. So this means that your container is quickly registered and can serve traffic at a faster pace. So yeah, it's a definitely a cool feature.
That definitely does sound cool because, again, some of the projects I've worked with use things like Dart for containers, and we had real issues with them taking 30 seconds or a minute to come up, and then so the Kubernetes scheduler just sort of going, the container's running, I can send it traffic, and it wasn't ready to do it. Historically, the way you dealt with that was you put some, I forget the name of the term,
Health
you basically,
check.
you put a health check on and said it wasn't, it wasn't able to serve traffic until the health check started passing. So that's kind of how we dealt with it. But it meant that the deployments, which would have been a few seconds, ended up being 2 or 3 minutes. And granted, in the scheme of things, that's not horrible. If you've ever worked with Java applications before, or if you've ever built an app
Yes.
for iOS, that's not terrible. But it's still awkward, it's still difficult, and it's still a pain to deal with. So this does sound really cool. This sounds like something that we ought to be taking advantage of. But as I say, I'm really unfamiliar with Seekable OCI. I don't know, how does this index actually work? How is it? What's it pointing to?
It points to the layers or the things that you have deployed in your image. So the signatures and the SHA of the image does not get changed. It whenever you push to a ECR, the SOCI index, the Seekable OCI index, gets appended to the image as another metadata field, and that can be used.
What? So it's loading the layers in kind of rather than
Lazy
sequentially,
load,
it's loading them
yes,
in
lazy
parallel.
load. Yeah,
Oh, cool. Rather than having to pull every single one in, it pulls them as it
correct.
needs it. I like that. I do. How did you pronounce that? Saucy? Saucy?
It's up to debate because it's a new feature. there are always two or multiple schools of thought. I would like to call it as so SOC I, or because it reminds me of the system on chip architecture. So
Mm. Yeah, that's often a debate we have both internally at Logicata and on LogiCast as well. Is how do you actually pronounce that?
yeah, yeah.
So we've
I
had
am pretty
DKIM being
flexible with any.
DKIM, and I think I'm going to go with saucy because that just sounds a bit weird. I'm going to go with
Yeah,
saucy, and then no
it's
one will know what I mean.
fun.
Okay, so in the article, it does actually say how you go about using this. You can either build the index yourself, or you can use AWS's tools to do it. What do you think? Which would you prefer to do?
The default way, just push and let it do its own magic.
I mean, I'm not sure what the advantage of doing it yourself would actually be.
Does
If
it?
AWS is going to build it for you, I don't understand. Again, maybe this is me not really understanding containers to the
It
level
would
that.
make sense in some use cases, like if you have some injection of parameters into your images. So basically, you could have some fine-tune control on that. But it depends. I would prefer it to keep the default setting. But yeah, it depends on the use case.
Yeah, I guess that's sort of the point, and that's the point with a lot of these sorts of things. Is by and large, let the tooling do it for you. But if you know that you have a specific use case to do it, you can go and do it yourself, which is kind of handy. Lots of links in this as well, so you can kind of go through the article that it links out to from our original post, and then that links out as well, so you can go and look at the index builder and how CloudFormation and EventBridge is working with all these things, so you can get a really good look at this. But this is definitely something that's quite interesting, especially for folk using containerized workloads that take a little while to come up, because again, using some of the previous examples, some things you probably don't need it because it comes up pretty quick anyway, but other things that have larger images, Ruby, Java, those kinds of things, it's going to take a little bit longer to come up. So definitely worth looking into.
Yes.
Moving on to our third article, and I feel like we're running through these very quickly, but if we're short, we're short. Oh well. We have a Let's Architect on the AWS Architecture blog. This is Let's Architect DevOps Best Practices on AWS. Now, you are a newly minted senior or lead?
Lead. I
Lead.
was
Leader.
previously a senior DevOps engineer, and now
Okay. Okay. So you're a newly minted lead DevOps engineer. I'm a lead cloud engineer, which basically is DevOps on the cloud in, whatever you want to call it. What do we think? It's good that they're putting out some best practices and things. What do we think about the things they're talking about?
So it talks about CI/CD and how CI/CD should be done in terms of AWS scale. But I think most of the customers are not having a AWS scale. So what they are initially trying to say is you should deploy at phases and at stages and gradually promote, or once you are very sure of the blast radius, and if things are looking fine at a zone level, only then you promote it and do it at a region and go on, so on and so forth.
Blast radius is an interesting term to pick up on because one of the things that we certainly see with customers that are, say, less mature in their AWS journey is they might all be running in one account still, and there might not be great or any segregation between development, staging, production, and all that kind of thing. It's a very common design pattern for folk that are not very far along into their cloud journey and have historically just worked on kind of servers and things. So blast radius is an important one to pick on there because, as you say, if you're pushing directly to production, you could have a fully automated release process, but it's still going to break everything. It's not, fully automated processes are not the be all and end all. They're not everything. It's important to make sure that you are building tests into these and that you are, as you say, limiting your blast radius so that if you do have something go wrong, it's gone wrong
Yes.
in a way that hasn't impacted your live running service. That being said, as you said at the start in your little intro there, if these things do inevitably happen, which they do, I mean, you work in tech, you've broken production. Everyone has broken production if they've worked in tech. It's almost like a badge of honor. It's a rite of passage. Everyone does it. It's important,
Yes.
and again, through this, that you have a well kind of trodden, thought out, battle tested, pick an adjective, way of rolling back to a stable state or rolling forward to a stable state. I don't know if this is talking about that particularly, but
It is also talking about fitness function, so which is a interesting take really, because as humans, they generally get better when they exercise, they get into shape. Similarly, deployments, once you have enough metrics and from past data, you could have more refined pipelines and refined flows if you try to understand the breaking points or things that usually get messed up and at which stage. So fitness function is really something which everyone in the DevOps should take into consideration and bring it into their tool belt. So yeah, that is a very exciting concept, and I would personally like to implement some kind of that to make the pipelines more safer and more reliable.
it's a very interesting one. I mean, this article, for those that haven't read it whilst they're still listening to us, so if you've not read it yet, what this article is, it's basically a short article that's a link to a whole bunch of other articles. And it talks about things like CI/CD being your, quote, release captain. God, I hate those terms, but, being sort of the king of your world in the middle of your universe and all the rest of it. It takes you out to that. It shows you kind of all these nice blue-green architectures and deployments and things. And then the next piece is using cloud fitness functions to drive evolutionary architecture. So again, it goes out to another kind of series of blog posts on the AWS architecture blog, and that talks about how you can write functions that test the fitness of your application, and that's things like your user metrics, your AppDex scores, or security holes and logs that are coming out to security and all those kinds of things. And it talks about observability and so on and so on and so on. And it gives you a nice little example of one. It talks about logged in. It talks about events going out to CloudTrail, and then you can look at the number of SSH sessions. And the idea being that the more sessions that people are logging in to your EC2s where the application is running, the less fit your application is, because people are having to kind of go in and diagnose and kind of do things and massage the application and so on. So it's an interesting one. It's a lot less clear cut and obvious than, say, an automated regression test that says yes, it all works, and much more of data over time, soak testing, I think it's called. I've certainly called it that before, where you've run the application for a good little while and then you've got a metric of some description that says, how much work have I had to do to keep this application running? So that's certainly a very interesting metric to start looking at. And as you say, people get better as they exercise, and your system gets better as it runs.
So one more thing which I'd like to add is, this seems a bit more into prescriptive guidance of AWS and AWS best practices, rather than what it generally recommends to all customers. So not every customer can apply all of the points which mentioned over in the blog post, but certainly the best practices and the things which apply to your use case and your scale definitely are good to have.
That's a very good point to raise, to be really honest, because I mean, one of the arguments that I've had with people before is, Netflix deploy 20,000 times a day. Other streaming services are available. We're not them. Once a day is more than enough. Like, it's fine. We're trying to get off once a month, for crying out loud. Once a day is plenty. Going from once a month to 20,000 times a day, it's just obscene. So it's always what is appropriate for your workloads. And yeah, it might not always be appropriate to, say, use that particular how many times have people logged into the server metric, when part of your workflow is occasionally logging into the server to move some uploads around or something, because you haven't automated that. So that's not always an appropriate thing to be looking at. But yeah,
Yeah.
definitely
So,
some
so
good
in
pointers.
Yeah, in our org we do on-demand deploys and multiple deployments a day. So yeah, that's our how we do.
Yeah, it's a thing. It's a thing. But yes, some good tips here, some good things to look into. But just, beware of trying to overfit your workload to their model rather than using their kind of tips. Speaking of models, finance people like models. Let's talk about money. We like talking about money on LogiCast. We certainly like talking about how much money that people are spending on cloud. So let's do that. Our next one is an article on SiliconANGLE. I always say that wrong. A report from Gartner: worldwide cloud infrastructure spending has topped $100 billion for the first time in 2022. Now, obviously, we're halfway through 2023 at this point, so this is it's not new, I suppose, but I guess the data's kind of finally been ingested and worked out and all that kind of thing. Most of that spending, as ever, is in infrastructure as a service. because that's kind of what this is talking about. It's not talking about cloud generally. Cloud spending is obviously quite a bit higher than that, but infrastructure as a service, so that's EC2s, RDS, I guess, anything where you kind of provision a server, so Elasticache, and so on and so on. Anything that you get an EC2 bill for is saying that it has now passed, across all the major providers, $100 billion for the first time, growing the best part of 30% year on year. I mean, that's huge. That's massive. I don't know if you've got
Yes,
any
it's not
thoughts.
surprising. I think we are on that scale. Yeah. The only thing surprising over here is GCP is in fourth rank. I expected it to be on the third. So
Yeah,
yeah.
I mean, when we talk about the quote big three quote, it's AWS, it's Microsoft, Azure, I don't know how you pronounce that, and it's GCP. And then you start talking about things like Tencent and Alibaba and IBM, and all you kind of talk about those in the same breath. But Alibaba is actually the third biggest, bigger than GCP. But I suppose,
Yeah.
I don't know, that might be a Chinese local workloads thing, that might be a data sovereignty thing, and certainly outside of, say, China region, it's not a provider that we would think to use because it is very China focused. And obviously, unless you're running workloads there, it's not a provider you'd really consider.
Yeah, so it is mainly for mainland China and the China specific workloads because they have some more restrictive compliance requirements and with the deep packet filtering thing and the China Great Firewall of China. Every cloud regulation is different in China. So yeah, they have to have their own servers and own stuff. So yeah.
It's an interesting one because AWS does have a China specific region. They do have kit out there, but I don't know if that's just an anti-Amazon thing. That's a wanting to use kind of the national provider. It's interesting. It's certainly interesting that they're bigger in revenue than Google in the infrastructure space. I did not expect that.
Yeah. But Google
Anything.
has done the most growth in terms of revenue, other than the main providers.
Yeah, that's an interesting point. We've seen this a couple of times over the past few years where Google is third or fourth, but they've consistently had the highest growth. But this is growth as a percentage, not growth as a number. So
Mhm.
even though they have a higher growth percentage than, say, AWS, and I'm sure it says it here in the numbers, but I suspect AWS's actual numbers have gone up more than Google's. But as a percentage, because they're working from a lower starting point, Google's percentages are higher.
Yeah, AWS always had the first mover advantage in cloud space.
Yeah, you're not wrong. You're very not wrong about that. In terms of percentages, it does say in the article. I can't find it off the. There we go. AWS is 40% this year of the market versus 38% of last year. Microsoft is now
21%.
21.5%,
Yeah,
and yeah, which has gone up by about 1%. Google is the fourth place, which is with 7.5%, and Alibaba is, it doesn't give me a percentage, but it has about a, what is that? It's saying it's about $1 billion more of spend, I think, which is, quite a lot. Yeah, really interesting. As you said at the start, and we said a couple of times, did not expect Google to be fourth. Really didn't peg that.
yeah,
It is also worth noting as well that about 19% of the market is from smaller providers that aren't the kind of top 4 or 5, because it does say that Huawei has their own cloud provider in there as well, which again is not something that you really use outside of China area. And these smaller people are going to be like, they're going to be IBM, they're going to be Hetzner, they're going to be kind of your boutique providers, if you like, but they're still taking up kind of a reasonable chunk of the market. But that chunk of the market has shrunk. So previous year it was 18.9% of the worldwide market. Sorry, it was 20%, and now it's 18.9%. So it's gone down a little bit over a percentage point, which suggests that people are moving away, maybe not in droves, because there's probably still some workloads that are appropriate, but they're moving away from your smaller, more kind of boutique providers and into the mainline players.
yeah. So it's always that case. The top line growth is mostly driven by the leaders of the industry, and the things which aren't in that rank, they generally get listed down. So yeah, always the top 4 or 5 players who bring in a lot of action, and that's the case.
Mm. That being said, let's move on to our fifth and final article of today, which is talking about sustainability. Now, this was talking about sustainability at the London AWS Summit, which I attended, which was great fun. My feet hurt a lot at the end of the day. My back hurt a lot because I made the critical error of taking my laptop with me and then didn't use it at all. So I was in real pain by the end of that. But sustainability was a key talking point. So in the keynote, and this is kind of what this talks about, the MD, VP, I have to pick an acronym, I don't know what our job title was, MD for AWS in EMEA, got off real quick about talking about sustainability, and then one of the customers, Rup Global, I think it was talking about sustainability as well, and it's like talking about some things like using satellite imaging to work out where you could plant trees and all that sort of thing. So I don't think you were at the summit, Omkar. It's a bit of a trek for you. I don't know if this is the same sort of
No,
thing at
I
summits where
just
you've
read
been.
the article, but no, I haven't been to the London Summit, but I have read the article.
Yeah, so I don't know if this is such a thing that's spoken about in areas sort of closer to you in sort of summits and events more where you are, but certainly over here, and certainly in the news media, it's a really big thing.
Yes, sustainability is a real challenge, and everything like being having a low carbon footprint and maintaining costs at the level that we are not doing harm to the nature is a real pain point, and it is stuff that everyone should be talking more about.
Yeah, I mean, the tech involved in it was in this particular keynote was really quite cool. I mean, we didn't really speak about it afterwards on this or in any of our other kind of media that we put out, but some of the tech that they were talking about with using things like ground station, looking at satellite imaging and using some data and all the rest of it to kind of say we've got about 45% of the available space that we could be using for things like carbon capture and air filtration and all the rest of it has actually been allocated. So we've got a load more that we can do. And it was really quite an interesting sort of little presentation. The other thing I want to talk about, though, which we have spoken about on the podcast before, and it was a little bit kind of a what does that even mean type thing. So if you scroll down through the article, it talks about being water positive. So this wasn't something that came up at the summit particularly, but this is something that came out a few months ago now, because we've spoken about it on the podcast before, about AWS's game initiative to be putting out more water than they're taking in. So obviously AWS's primary thing that they do, I mean, we consume all their services, but the thing that they actually do better than anybody else, in my opinion, is run data centers. Data centers need water for cooling because servers run quite hot and they run better when they're not hot. Great. Water cooling is a thing, air cooling is a thing. Water cooling is generally more efficient because you just transfer the heat directly into the media and off you go. The idea behind being water positive is rather than taking X amount of water from a water source, using it, putting it back, that would be water neutral, just about, maybe water negative because of evaporation and off gassing and all the rest of it, is rather than taking water from, say, rivers and lakes and aquifers and all the rest of it, they're capturing water from, say, the rain, because they've got enough buildings, they can certainly do some rainwater capture. And things like that, and recycling the water that they're using in their facilities and all the rest of it so that they can take less water than they actually need from these sources and then putting more water than they've used back into the environment, which, given news of, say, Canadian wildfires and what's going on in, I think, various bits of Greece at the moment, and we certainly have had micro droughts and periods of extended no rainfall in the UK, that's absolutely something that companies generally need to be getting better at, I think.
Yeah. So the Internet of Things and sensors, it really fits into place how we could use or formulate a solution which would drive all these goals. And yeah, it definitely makes sense. Also, one more thing which I would like to add is the main point highlighted that AWS is trying to be a resource, or they are trying to 100% use renewable energy by 2025, which is a tall claim. But if that happens, then and migrating all on-prem to AWS cloud is a single and surefire way to do good to the environment.
I mean, that's a thing. That was definitely spoken about in the keynote as well, where migrating to the cloud was definitely accelerating people's journey to net zero. Because, I mean, this is a thing that I've seen, before I worked for LogiCast, but back when I worked in other jobs and things, where people were talking about moving from disparate servers to colo, and then from colo to data centers, and then from data centers to cloud, and all the rest of it. It's resource density. You can dress it up as much as you want. It's resource density. The more you can pack into the same amount of compute power, electrical power at the end of the day, the less you actually are spending in money and in carbon and all the rest of it for that amount of output. So yeah, I think what AWS has done, and what generally the hyperscalers have done, is kind of force that issue by proxy by saying, put it here, we run data centers, you don't have to run your data center because we'll do it for you, just pay us a little bit extra. And then everyone's gone, great, I don't have to run my data centers, and it's all been coloed, so we're running fewer data centers. I guess that's the theory.
Yeah. Yeah, agreed. Yeah, economy of scale works really great for hyperscalers.
And I think that's all we have time for. Nice little timing segue there. So that will be it. Thank you to Omkar Kadam for joining us on episode 28 of season 2 of LogiCast. It's been an absolute pleasure, and I have fumbled my way through this enough. Karl, please come back and save me. You can download this podcast anywhere you get your normal podcasts. It's on YouTube, it's on Spotify. Please do go and download and subscribe, because it makes our internal graphics great. It really does. But that's it for this week. We will see you again next time. Cheers.
Thanks, John. Thanks for having me. I really had fun discussing everything with you. Thank you.
Oh, it's been great. It really has. Thanks for listening, everyone, and we'll see you next time.